Welcome to Highline BI 348 class video number 64. Hey, if you want to download this workbook, BI 348 chapter 11 video 64, click on the link below the video. Hey, this chapter is chapter 11. We're going to talk about the amazing Monte Carlo simulation. Now, we actually have 6 videos, and in this video, we're just going to have a basic introduction to Monte Carlo simulation, and we're actually going to compare modeling that we've done earlier in the class and see how it's different than a Monte Carlo simulation. Then in our next video, we'll talk about creating random variables, which is the essence of a Monte Carlo simulation. And then we have 4 awesome examples. Now, before we go over to our next sheet, look at this. I left the sheet one. I'm going to double click this and call this topics. All right, now we want to go over to the sheet and talk about what's not a simulation. So we're going to go to the sheet not simulation. Now, we've done this earlier in the class, chapter 7 and other chapters. We built a model. We have our formula input area, also called parameters, assumptions. We have decision variables. But here's a new term, set or static variables. So far in this class, all we've had are set static variables. And what does that mean? We have price, demand, total fixed cost, and variable cost per unit. Each one of these is a single number. So when we come down here and we build our model, notice earlier in the class we always built our math model to express the logic of the formula, and then we build our formula. So I'm going to build the formula with what are called set or static variables, equal sign, the demand times open parentheses. And notice each time I click on a cell, there's the price. It's just C3 pointing up there. It's a single cell looking at a single number. Those are set static variables. I'm going to say price minus variable cost per unit, close parentheses, minus total fixed cost. Now notice 4 cell references, 4 formula inputs. When I control enter, it calculates the profit. If I change one of these formula inputs, again, this is set or static variable, notice I'm changing it. So it's not really set or static because I'm allowed to change a formula input. That's the whole reason that Excel was invented, right? But watch this. I'm still only putting one number into the formula. So when I change the price to 20 and hit enter, instantly the formula updates. Now, the 2 important things about a set or static variable is, the first thing is there's a single formula input and there's a single output from our formula. Now, let's envision a different situation. All of these numbers are our best estimates. But what if when we got to estimating product variable cost, we absolutely have no confidence that it's going to be exactly 15. But perhaps we're confident that the range of prices could go from $13.50 all the way to $16. That would be a random variable or an uncertain variable. And that's the essence of what a simulation is. We're going to have some variable that's not certain, and we're going to need to throw many different possible potential values for that variable into our formula, and we will get many different outputs. That's the simulation. Let's go over to the sheet simulation and look at our first example of an uncertain random variable. Now, here's our same formula inputs, parameters, assumptions, decision variables, set static variables, price, demand, and total fixed cost we'll assume are set or static. But the uncertain variable will be product variable cost per unit. Now, luckily, the accountants were paying attention. They built this relative frequency distribution from purchase information this year. And we're going to assume that the purchase information from this year will be relevant for predicting next year. But here it is. Prices $13.50 up to $14 happen 20.5% of the time. 14 up to $14.50, 18.5% of the time. All the way up to $15.50 up to $16. 20.75%. So anytime we have an uncertain random variable and we need to use it in our simulation, we have to know something about the distribution of that variable. Now we went ahead and plotted this, and sure enough, it looks like a uniform distribution. The next step is then to use that knowledge of the distribution and create an Excel formula that will randomly generate that variable. Now, before we do that, I want to go over to our PowerPoint slides and just remind ourselves from our prereq class of some of the distributions we saw. Discrete probability distribution. This is 2 videos ahead. We'll have direct labor cost, and it won't be a continuous. It'll be either 39 or 40 or 41. Notice we plotted this from our past data, and we can see each one has a different probability of occurring. We also saw other discrete probability distributions, such as the binomial probability distribution, where we had a certain number of successes and n number of trials. Another distribution, hey, this is the continuous one we're going to use in this video here. And we also saw things like the normal probability distribution. And a couple videos ahead, we'll have a demand variable that'll follow this distribution. So knowledge of the actual probability distribution is required if you're going to do simulation. Now let's go back over to Excel. All right, here is the min. Here is the max value for our range. We know our distribution is continuous, approximated by the uniform distribution. So watch this. In Excel, there are a bunch of great functions for randomly creating variables. Now, the rand function and the RANDBETWEEN function follow the uniform distribution. In this video, we'll look at the RANDBETWEEN. Next video, we'll see RANDBETWEEN, rand, binom inverse, norm inverse, VLOOKUP, and a bunch of other functions for creating random variables. All right, in this cell right here, I need to randomly create numbers between 1350 all the way up to 16. Hey, the RANDBETWEEN function is amazing for this. All you have to do is give it the bottom and the top, and it will generate random numbers following the uniform distribution. All right, so you ready? We're going to start off with just a simple example. Hey, I'm going to click on the min, comma, and the max, close parentheses. Now, when I enter this, it's not going to exactly work correctly, but we'll see that it does randomly generate numbers.
16.
Control Enter. Now, you have to hit the F9 key, F9, 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 F9. Each time I hit the F9 key, it's randomly creating a number based on the min, the max, and the uniform distribution. Now, that's not exactly what we want, so I'm going to hit F2 to put an editing mode. I really want $13.50, $13.51, $13.52, all the way up to $15.99 and $16. So I'm simply going to multiply each number, min and max, times 100. If I Control Enter and hit F9, you can see I get $15.99, $15.27, $14.75. Not what I want. I need to slide the decimal 2 times. So F2, divide by 100. And there is our formula to randomly generate numbers based on the uniform distribution and our past accounting data of min and max. There it is, F9, F9. That is beautiful. Now we have to create our simulation, which means we have to throw that number, that formula, into our model and then simulate it many times. That means we're going to have many output values. Now, before I do that, I'm actually going to hide. So I'm going to hide all of these. I clicked on row header, held Shift, clicked on 7, right-click, and hide. All right, so you ready? This is going to be pretty amazing. Equals demand times, in parentheses, the price. Those two are static. Minus our variable cost, random uncertain variable, close parentheses, minus another static input. By the way, this video we have just one uncertain variable and a bunch of static. We could actually make all of these have a range of values based on a distribution, and we'll do that in a later video. But here, Control Enter. Now if I hit F9, F9, whoa! So you could see that that's a good profit. But once in a while, we're going to get a loss. So Let's run the simulation. The simulation will actually repeat this, and we're going to do it 10,000 times. And the beauty of that is we'll have a full range of values, and we can create a relative frequency distribution to calculate the probability of each outcome. And it will tell us, as a decision maker, what's the probability of getting a loss. Now, if we were to put that whole formula in the cell and copy it down 10,000 times, it would work, but it would calculate really slowly. So there's a great trick in Excel. You set up your one formula with formula inputs, including a random variable. And we're going to use the data table feature, which will, in essence, copy this formula down 10,000 times. And it will calculate much faster than if we actually created all the cells with regular formulas. Now watch this. I need to have my number of simulations go from 1 down to 10,000. So we're going to learn a great trick. I'm going to point to the fill handle in the corner. And when I see my crosshair or angry rabbit, right-click, drag down, then drag back. I'm right-clicking, remember. And when I let go, a secret menu pops up. And I want to point to series. Now in series, I want to say fill the series down the column. The step value is going to be 1, and the stop value is 10,000. When I click OK, instantly it went from 1, control down arrow, to 10,000, control up arrow. Now let me control Z. I always do it this way, right-click, pull back series. But in case you forget that, you can go to Home, over to Editing, Fill, and there it is. Series will bring up the same exact dialog box. Columns. By the way, I forget this all the time. I say 1, 10,000. If I click OK, it's going to shoot the numbers in the row. So be sure and say columns. I'm sure if you start doing this for the first time, you'll make that same mistake, and it destroys everything. So be careful. Click OK. All right, you ready? The way a data table works, and we learned this back in Chapter 7, is you have at least one formula at the top. We put our variable that we want to substitute into the formula off to the side, and the data table will make the substitution, except for this number has nothing to do with our formula. The beauty of this is, you see over here it says data table column input empty cell. That's the trick to get the data table feature to copy this formula that has nothing to do with these column inputs down. All it will do is it will just get it to randomize many times. So you ready? I'm going to highlight formula, Control-Shift down arrow. All of these numbers here are theoretically our column inputs. Data, data tools, what if analysis, data table, or the keyboard Alt-DT for data table. Nothing for row input. Column input, you can click on any empty cell, but I would be careful. I would be sure and label it so that we're not going to mess with this. We know exactly that cell is being used in our data table. When I click OK, that is simply amazing. Now I'm actually going to Control-Shift down arrow and add some formatting. And there it is, the data table. And you can see up here there's that array formula that's entered in. There's no row reference, so it says nothing, comma, and then there's the column reference right there, an empty cell. In essence, what the data table feature in this table array function did is it tried to substitute these in based on this cell here, but because it has nothing to do with the formula, it just copies it down and it randomizes. You can try this on your own. You can copy a randomized formula down 10,000 times and then see, not always, but most of the time, it'll really bog down your calculations. Every time I hit F9, it calculates quickly. So the data table feature really does us a great benefit when we're doing simulations, in that it speeds up the calculations. Now, all of these numbers here we now use for our analysis. We need to calculate the mean, which will be one estimate representing all the simulated values. Standard deviation, what's the min possible loss we could have? What's the biggest gain? What's the probability of actual no gain or a loss? So let's come over here and equals count. We're going to count numbers. Click in the top cell, Control Shift down arrow, Control backspace. And I'm actually going to click on this value 1 to highlight that whole range and Control C to copy. Enter. All right, so we have 10,000 equals average. Here's our mean, Control V. So 1,274. We could use that value to make our decision. Hey, now that we've run our simulation, on average, we're going to have a gain of 1,274. But that's not the complete picture yet. We also need to look at variation of the sample, Control V, and Enter. So it looks like quite a big variation in this data set. We also need to see what the min, what's the worst possible loss we could have. Control V from our simulation, it looks like minus 1,400. The biggest possible profit, Control V, 3,975. We can also ask the question, hey, what's the probability of no gain? That means 0 or a loss. Count ifs, Control V, comma, and the criteria, and I'm going to hard code this in double quotes, less than or equal to 0, close parentheses. Now that'll count all of them. Divide by the total count will give us, and I've already formatted this, so it'll give us the percentage, 26.07. Now if I hit the F9 key, notice these are changing, and so are these. So there is some variation in each simulation that you run. Now this is good analysis, and in particular this one right here, the probability of no gain or a loss. That could help the decision maker decide whether they want to run this product or not. But the full picture is going to be our frequency distribution. So we want to scroll down here, and we want to build a frequency distribution, and we're going to use the frequency function that we learned back in Chapter 2. I need to figure out the upper limits for each one of my categories to count. I'm looking at the min and the max. So I think I'm going to start at minus 1,500. And it looks like I need to go up past 4,000. So watch this. I'm going to use my same trick. I'm going to point to the fill handle, and when I see my crosshair, right-click, drag down, drag back, series. I'm going to say fill down columns. The step value, I'm going to make it 500 tab, and we're going to stop at 4,000. Click OK. So instantly I have my upper limits. Now for the frequency function, this is an array function. It'll use each one of these as the upper limit for counting. So this category right here, the count that's going to be in this cell, will count everything less than or equal to minus 500, but bigger than 1,000. All right, so with array functions, since the frequency function will deliver one more value than number of upper limits, we highlight that number of cells, and then the active cell equals frequency. It wants the data array, Control V, that's that range for our simulated values, comma, the bins. I want all of these. Those are the upper limits, close parentheses. Now this is an array function. You have to enter it with the special keystroke, Control-Shift-Enter, and it will simultaneously enter and deliver all of the frequencies to all of the cells. Ready? Control-Shift, and Enter. There's the values. We told Excel that this is an array function by Control-Shift-Enter. But don't forget, when you're doing array functions, look up in the formula bar. Do you see your curly brackets? That's Excel telling you I understood it's an array formula. So it looks like it's working. There's our frequencies. I want to go ahead and calculate the relative frequency, our estimated probabilities. I'm going to take the particular count divided by, and I should just do it down here. Watch this. That's going to be the total at the bottom, and I'm going to lock it with F4, Control-Enter. Copy it down. Come down here, Alt equals, to add up all of the frequency counts from our simulated values, 10,000. We get all of our relative frequencies. Now I went ahead and added the explicit categories to remind you how the frequency function works. If we give it the first upper limit, counts everything less than or equal to that. All of the categories in between the min and the max upper limits have an x in between where the upper limit is always included, but the lower limit is not. We come all the way down to the last one. And the reason frequency adds one more count than there are upper limits is because it counts everything above that last limit. Those are the explicit categories. Now I'm going to add some number formatting to show our relative frequencies or estimated probabilities as a percentage with 2 decimals. Because here's the real power of simulation. I can clearly see the probabilities associated with different outcomes. So for example, the probability of getting 0 or less profit, we add all those up. That's the calculation we did up here. We can also add all these up to get the probability of getting a profit. We can look at a specific category between 1,000 and 2,000. The probability is about 20%. If we hit the F9 key, you see these are randomizing, so these update. Now, this is a uniform distribution, and we only have one variable, so these should all be pretty uniform. In later examples, we'll have multiple different variables in our simulation. This is the advantage of simulation. We're able to see various outcomes and the probabilities associated with each. Now, let's go over to PowerPoint and summarize. I'm on slide 13. What is a Monte Carlo simulation? When your spreadsheet model has formula inputs that are uncertain, rather than provide just a single formula input like we've done so far in this class, Chapter 7 and others, we have to supply a range of inputs, and thus the model will deliver a range of output values. We then look at the relative frequency distribution created from the range of output values to learn about the estimated probabilities for model outputs. In this way, we can provide decision makers with estimated probabilities for uncertain variables so they can assess the risk of undesirable outcomes and the likelihood of desirable outcomes. Now let's go to slide 16 and review the steps for our Monte Carlo simulation. Step 1, create a spreadsheet model using good spreadsheet model guidelines. Number 2, determine the set or static variables and the uncertain or random variables. Step 3, from past data or other information, we have to estimate the probability distribution for our uncertain or random variables. Step 4, build randomized formulas in Excel. In the next few videos, we'll see various ways to create random variables. In this video, we saw the RANDBETWEEN. Step 5, create a simulation using that awesome Excel data table feature and the column input pointing to an empty cell. That one speeds up calculation. 6, we analyze simulation data with mean, standard deviation, min, max, relative frequency, and other techniques for analyzing. And finally, the main advantage, decision makers can see the full range of possible values and the likelihood or probability of each potential outcome. Now, in our next video, we'll look at various ways to randomize variables in Excel, looking at various distributions. And then the 4 videos after that will have 4 awesome examples. All right, we'll see you next video.